It's a really easy question.
I think what we're talking about is what's at the very edge.
Hello and welcome to the Edge Tech Podcast, where technology meets the edge of innovation. I'm David Kosloski. Today we're talking about AI and edge. Why does it matter? Alongside of me, I've got Ed Barkhuysen, who is the VP of Product, and Matt Forde, who is the Sales Director of EMEA. Thank you guys so much for being on the show today and talking about AI and the edge. Now, we've talked a lot about edge, and I think we've also mentioned that there's sort of like an unconscious knowledge that AI has been implemented with the edge. So I want to start, Ed. Can you explain a little bit about edge and maybe what it was before AI, or rather the decisions that are being made without it?
Yeah, sure. So, I mean, AI has been around for a long time. We can come back to that perhaps, but edge computing has also been around for a long time. And it's been quite cyclical as edge computing has moved as far out as you can away from the data center and then being pulled in closer to the data center. And that's been cyclical around CPU enhancements and improvements in the level of performance of compute that you can get from a server-like system to a smaller, more power-efficient system out towards the edge, and then the level of connectivity that's supported that as well. So there has always been a movement between the edge and the data center, and what we're seeing today is levels of compute performance that we've never seen before, tied in with levels of connectivity that we've never seen before, with satellite-based communication systems being easily deployable, along with 5G networks. So now I think it's all coming together, and we're really seeing that tying in. So AI is an important part of that, but whether you look at that from an image rendering point of view, or even perhaps a local connected backup system or data manipulation, a lot of that still happens at the edge and needs to be close to the consumers and the users that are using that level of compute without necessarily bringing AI into it. So they are still two separate fields, but definitely they complement each other.
Yeah, and Matt, you had some good examples before we started, specifically around surveillance. I think it's a funny example, but it's a serious example about breaking and entering. Can you give that example?
Yeah, so there's in terms of what AI is at the edge and how that affects the companies that we work with, the partners that we work with. So we do a lot with retail, we do a lot with QSR. I think maybe as a foundation level, it's important to just point out the difference of what can be done in the cloud and what can be done very efficiently at the edge. So for a retailer, if you look at start with the problem statement. So what's affecting retailers today? And one of the things affecting retailers is getting labor. It's a real challenge. It's opening your store. We have customers in the US who operate QSR, who in 40% of their locations, the store itself is not open to sell burgers. The drive-through is open, but the store is not open because they can't get the staff. So where does AI help with that? And you have lots of people who can use a camera to count the number of people that are coming into your store and be able to give you predictive analytics as to how busy you are in the morning, when's your busiest time in the afternoon. And that can all be done in the cloud. In terms of counting people, gender recognition, all that piece can all be done in the cloud. But if you're a QSR operator and you're trying to figure out how do I optimize my queue times for my customers, or you're a post office and you're trying to make sure that you don't get fined because you have people waiting in a queue too long, that is information that has to be gathered at the edge, interpreted at the edge, and acted upon at the edge, because the time to act has to be done in real time. There's no point in saying I had a really long queue of people waiting for an hour at 9 o'clock this morning. It's too late. You've got to act on that within a couple of minutes to be able to solve the problem. So that's where the edge and having hardware at the edge allows these new AI models to work on the device itself that's at the edge. And maybe to challenge something that Ed said earlier on, which is about having, connectivity everywhere. Unfortunately, that's actually not the case. And you talk to a lot of retailers where bandwidth restrictions are a real problem. Getting bandwidth to a store, whether it be in rural England or in rural United States, is a real challenge. So, we work with customers who have to take all that video applications. And in the past, what used to happen was you took your video, you stored it on a DVR locally. And hey, what do you know? When you get broken into, the first thing the criminal goes for is the DVR. And he kills the DVR, so the evidence is gone. So that was why you saw a movement of, taking the video and storing it up in the cloud. And storing in the cloud, absolutely fine. Expensive. They don't tell you that when you're buying the camera. But when you do the analysis of, if I need to store my data for more than 30 days, it gets really expensive. And another side story, especially in the US, is where you have people who will come in, bad actors, and say, I had a slip and fall in your premises 45 days ago. And why do they say 45 days? Because they know the recordings are not there so that you can take a court case and defend that court case. But I went off tangent there, apologies. But for the edge piece, if you're looking for data to be interpreted in real time, that's when it has to reside on the edge. It would be the same for another big challenge that you're seeing, particularly in the US and retail in the US, is theft in retail has become a real problem. It's a multi-billion-dollar problem. And one of the ways to defend against that is if you're using AI at checkout to determine if someone is stealing something or not, paying for something or not, scanning something. So again, that information needs to be done in real time. And you can't do that in the cloud. You can't rely on your bandwidth to get that information up to the cloud and back again to be able to defend against that type of activity. That's the type of stuff that suits the edge. And that's why you're seeing an emergence of edge hardware that allows these applications to sit very comfortably and work really well at the edge.
No, I completely agree. And I think, some of the discussions we've been having in earlier podcasts around semi-autonomous systems out at the edge that are able to continue to operate when perhaps they can't get the data connectivity that's needed, whether that's just a bandwidth issue or perhaps the connectivity is dropped or perhaps in a location where that connectivity isn't available. We were talking about some extreme scenarios in very harsh environments, perhaps underwater or perhaps in space, where you need to be able to have a system that's able to have a model which it can follow and be able to do the AI inference out there at the edge, often with no connection to the cloud, or at least being able to operate to a level of semi-autonomous ability with potentially a limited connection back into the cloud or with other systems. So it needs to be a blend, but I think with the level of connectivity that we have today and the level of compute that can be put out there at the edge, it's giving a good level of choice. If you're a meteorologist looking at the last 20 years of weather data, that model is going to be in the cloud. You're not going to have that at the edge. But then again, the inference you're gaining from that may not need to be as real time as it would be, in a theft protection scenario where someone is potentially putting something in their pocket and within 10 seconds they are out of that door and down the street. And you need to get ahead of that. You need to have your security guards perhaps waiting for them, waiting to meet and greet them outside the door. So, as we look at the way that AI is being implemented today, there are, I suppose, three key areas that we're seeing it being used in. And you have to remember that AI isn't something new. If you were looking at language models that were being deployed over 15 years ago, a good example is Google Translate, where it's looking at a text in one language, but it's not just looking at it as individual words, it's conceptualizing it and providing a translation that would be meaningful in a different language. And I think various evolutions of AI have given extra visibility to it from a public perspective, but as we're seeing it being deployed right now, it's visual monitoring, predictive maintenance, which we've touched on a little bit as well, and then operational efficiency. So those are the three key areas that we're seeing it being used in today. But that's going to grow and change. And there's a particular report I think from IBM just recently doing an analysis of the level of change that we can expect. And they were saying that the impact that the mobile phone has had on society will be nothing compared to the impact that AI is going to have over the next 10 years.
Makes me wonder, when we talk about AI, where does AI inference play a part in edge computing? And maybe we need to start with, what is your definition, either of yours definition of AI inference? Because I feel like the terminology can get very skewed from person to person.
I think when you have a trained model, which you can then use at the edge to make an inference. It's not Gen AI. You're not going and generating something which, a human might be otherwise, but AI is now doing that instead. Classic example of that, an easy one is text generation. So as you start writing a message, it's trying to complete your sentence for you. A really good example, and something perhaps you wouldn't want in the cloud is, say, for example, your office is controlled through facial recognition. And as you approach that, that's AI inference looking at your face and then unlocking the door for you.
Yeah. And by allowing the AI inference to happen at the edge, like what's the big impact there versus a cloud solution?
So its speed is one thing for certain. You can't, if it was that particular example, you can't wait, 30 seconds for the door to open.
Yeah.
Unfortunately, that has to happen, within 2 seconds, or you're going to have a very frustrated number of people. So I think that's certainly one. The other thing is about GDPR in Europe is, where do you keep that data? So, if you're seeing a big move towards wanting to make sure that data is all kept within your own silo, within your own control, in your own local area network, really, as opposed to it sitting out somewhere else where it may be compromised, or it may be compromised on its way to the cloud. That's one of the areas of concern of why that data would want to sit in your own control.
Yeah, and it's also so when we talk about edge devices and implementing AI, if it had to be in the cloud at one point, I'm assuming that was a very large system, like a server. Is that fair to say? When I say that, the hardware had to be large.
It's changed so much over years, but I think that's a traditional concept.
Yeah, and so today is these edge devices don't necessarily need to be large, right? Some of them can fit in cameras, or rather next to cameras. Is that fair?
Yeah, I mean, that's one of the big changes. Like I spoke earlier about what challenges do retailers have, and retailers generally do not like to have a lot of equipment on site. How do you manage it? It would be much easier for them to manage one central repository of information, or outsource it to a cloud provider to let them manage the kit. So they're reluctant to have large amounts of kit on site. And this is where, with companies like Simply NUC, who've got the new Extreme Edge server range, where this device is much smaller, you can fit 2 of them in a rack, and consume a lot less power. These things are actually important. We're working with a client at the moment where the power savings alone on moving from traditional large rack servers in store to small form factor servers in store was £4 million a year in power savings, which is, that's a big number.
Yeah, you can take the sales guy out of the desk, but you can't take the sales out of the salesman.
Sorry. What could you do with that £4 million, right?
Yeah, no, that's great. Do you see, like, based off what we know about AI models, does the machine itself need to be, you said 2 in a server rack, does it need to be smaller I guess, are we limited by how AI in terms of size? Does the machine need to still be very large? Can it keep getting smaller? Is there progression where the models maybe get leaner? That means the devices get smaller. Like where can we go with this in the future? Because if it is something that takes up a server size rack, you're still, I feel like there's a lot of wiggle room in the future. It should be the size of our phone, right? Hopefully in the future that can hold an AI model that can make decisions, AI inference on the fly. Is that possible?
There's a lot of effort going in right now into making large language models, which many of these solutions rely on, not just from an integrity point of view, so that what's in there is accurate and correct. A great example is if you were to go and create a large language model around Wikipedia, that would be so big that you wouldn't be able to normally have that right out at the edge. That would need to be stored in a centralized data center and then leverage there. But is that going to change? As the level of compute, the level of storage and memory capabilities are improved in those small form factor devices that could be placed out towards the edge, in tandem with the efficiency of that large language model and the operation of that. Yeah, absolutely. So we're going to continue to see a greater level of autonomy and deployment of these models out towards the edge. It's there today, it really depends on the scale of it. So if it was a more specific targeted model, perhaps in this theft protection example where it's looking at, where your hands are going, is your hand going into your pocket and there's something in your hand going into your pocket, and it's not, a mobile phone, it's a product from the store. And that's something which can be trained and can be leveraged at the edge today.
And that does exist today. And so are there any hypothetical ideas of where I feel like AI is in this infancy stage, even though you said, the Google Translate was happening, but ChatGPT came out, and obviously it was this boom rush of everyone's using AI, or a lot of people are early adopters. It comes across like it's still this unknown. Is that fair? Is that a fair assessment that we're learning still as we're building? And if so, what are the even potential possibilities that we're not even thinking of, especially around edge computing?
A good example. So back to the loss prevention model. Okay, so there are companies out there actively working on machine models that will count the number of items that are there in front of you on your till. Compare that to the number of items that were put through POS, so they can make a comparison to say, has your checkout operator checked through everything that they should have, or in the US they call it a term called sweethearting. Okay, so I'm giving product away to somebody that I know. Now, if the model is 90% accurate, then what the result of that means that you're going to have 10% of it is not going to be accurate. And if you have 10% that's not accurate and you're referring that to human inspection, that's a huge amount of human inspection, a huge number of transactions, which actually outweighs the value of having the solution there in the first place. So where AI will develop is to getting that to being 99% accurate. And when it's 99% accurate, then the data is worth more than the effort of inspecting it. So that's what you'll see of it getting better and better and more accurate. I think that's what you'll see from a development of AI across lots of different fields.
So to play devil's advocate, if the hypothetical is 10%, what would be the benefit of implementing AI at the edge today?
So the reason that you're seeing companies moving to doing the inference at the edge is that the models are getting more sophisticated. They call it AI, right? But it's not necessarily artificial intelligence. This is human beings who are building models that are able to recognize items, recognize different things. But the way the models are being built now is that you are, introducing levels of machine learning where the model knows, okay, I know what I'm looking for in terms of how do I build that, and I can create that quicker on the edge and do it on the fly.
You almost need or even though there's a discrepancy of 10%, you need the AI to continue to grow and actually work to then learn to be able to then shorten that 10% down to the 99 is what you're saying.
Yeah.
Yeah.
If you're counting the number of people who went to a store, if it's 95% accurate, that's really fine. It's okay. But if you're using it to detect theft, it's not. You cannot. You think of a situation, okay, in a retailer, and if you are stopping 5% of your shoppers at the door or 10% of your shoppers at the door because the AI model suspects that they did something inappropriate, you're going to have a serious problem of getting customers to come to your store if 10% of them are going to stop and search them as they exit. So that's how the models have to get much better from an AI perspective.
So I'll throw a curveball for you each personally, and it could be consumer-based, could be business-based. What are you most excited about in edge computing in the future that doesn't exist today? Let's say there's no size issue. It can be as small as you want it to be. What are you most excited about to implement AI in your own lives?
Me personally, fully autonomous driving. So we're on the road, if you like, going in that direction, but we're not there yet. And I think as you look at those almost containerized applications of AI, and with the evolution of large language models, Self-learning, as they're being developed around a neural network approach with weightings being attributed to various decisions that can be made, and that being constantly evolved and updated. When a particular car sees something happening and responds to it in a particular way, and that's deemed to be a successful way of dealing with a particular situation on the road, as a new driver, you'd have to go through and learn all of that. Different junctions you might need to pull out from, different speeds of cars and distances are all around you. Whereas with the model and the being constantly updated for automated driving, that'll be instantly distributed amongst all the cars. As one learns something, the whole network learns it instantly, and then that'll be an acceleration towards a much safer environment for us all to live in.
Sure. Matt, you got an opinion? I assume yours is going to be about golf. I was trying to see if you...
Well, I'm a proud driver of classic cars, so I'd be really concerned about Ed's future of... but what's interesting about the AI piece and the driving piece is that as that matures and it becomes so much better than it is today, the consequence may be that you will not be able to get insurance to self-drive a car because the AI cars, the automated cars are doing it so much better, less traffic because they learn and they say, okay, if they all slow down to 50, we're not going to have this back and forth piece. That is certainly one development I wouldn't want to see, and have my poor car sitting in the driveway. That would be a very sad indictment.
Acknowledges that's possibly inevitable, but at the same time hates it.
And I think there's no level of AI that could help me with my golf right now.
Fair enough. Is there anything that excites you personally?
No, I think I'd like to see it how it develops from. I'm a musician as well, so I'd like to see how that develops from a teaching perspective. I'm certainly not interested in seeing how it writes music and replaces musicians and replaces creativity, but I think there's a lot of potential from a teaching perspective in the music world. So yeah, and you're seeing some of it already.
Do you have any examples?
Yeah, there's lots of applications now. So if you're learning to play piano, it is actively listening to you, and it is listening to what notes you're hitting correct, and it's giving you positive feedback in the moment that you've hit the right note or you haven't hit the right note. So you're learning it from that perspective. I think there's a long way to go from that perspective. You see it for pianos and guitars, and I'm sure it's there for wind instruments. So yeah, that'll be interesting to see where that goes.
Yeah, I've seen apps that help you sing better as well.
Yeah, fortunately, I don't need that app.
Yeah. Fair enough. Awesome. Well, guys, I think this was a really great conversation about Edge and AI. Is there anything else before we close it out? I didn't know if you had any last...
Yeah, there was something that we didn't cover I think is important. You talked before about, that as the devices get smaller, that there'll be more and more devices. I think in parallel to what's happening there is that you're seeing customers wanting to consolidate on the number of devices. So what we're seeing, and it's happening now, it's happening today, is where instead of having, a device that does this and a device that does this, that what you're seeing, an appliance is generally they get called. So instead of having, 6 different security appliances from 6 different vendors, what you'll see and what you're seeing now is say, okay, I'll take the software version of that and I'm going to apply it on 2 devices. And these devices work as a redundant pair so that if one goes down, the other device takes over. Instead of having 6 devices, I have 2. Still 2 small form factor devices that do exactly what the other 6 devices do. Because again, back to space, not want to have, it's, you also don't want to have to, every IoT endpoint is a device that has to be managed by somebody. From a security perspective, every IoT endpoint, whether it be a camera or a sensor, is a security risk. So if you can consolidate that down onto as little numbers, as small a number of hardware appliances as possible, that's That's definitely happening. And as those devices, small devices, become more powerful, you'll see that, multiply and continue.
No, that's great. Ed, any last thoughts?
No, I would just end on saying, this is a very rapidly moving technology, and I think as individuals, but as organizations and companies as well, I think there are many fellow travelers out there who you can partner with to go and learn and combine solutions together. And I think that's going to be a key part of the evolution of this is bringing different technology partners together to go and create the solutions which are going to go and make a difference, in the world we live in tomorrow.
That's great. Well, thanks guys so much for jumping on the show and talking about edge computing and AI. And thank you all for listening in. Make sure you like, share, subscribe. Thanks for tuning in to the Edge Tech Podcast. Again, I'm David Kosloski. Take care.